So, now that we have seen how the planetary boundaries concept was created and how it can be used today in real cases, we're going to study the future perspectives. There are three key development needs right now for the planetary boundaries concept. The first one is solving the issue of unmeasurable boundaries. Most boundaries, you see, have a control or multiple control variables. For example, ocean acidification is measured through pH. The pH level in the ocean tells us for sure whether we are below or above the safety levels for that boundary. But each boundary does not have a control variable yet. For example, atmospheric aerosol loading is very complicated to measure. Scientists are working right now on a new proxy that will give us an idea of where we are right now in that boundary, in a safe zone, an uncertainty zone, or in the danger zone in red. The same thing goes for biosphere integrity. A key control variable in that is the resistance of ecosystems to abiotic shocks. This is a shock caused by humans on a natural ecosystem. For example, when humans starting to massively use DDT for agriculture, it increased the death rate of birds. This was the reason why the book Silent Spring was written. Once we stopped using DDT, the birds came back. This is resilience. But resilience depends on three things: the nature of the ecosystem, the nature of the shock, and the extent of the shock. For example, with overfishing, we don't know for sure that if we stopped overfishing right now, the fish population could grow back to what it used to be. There are also emerging threats captured by the boundary novel entities. In novel entities, we mostly talk about chemical compounds that we create every year. We also produce chemical compounds by the thousands every year, and we only know for a small fraction of them which are safe and which ones are dangerous. Scientists therefore want to work on defining a better control variable that would isolate the different chemical compounds that are created every year and distinguish between potentially harmful ones and potentially safe ones. And there's also work in developing a science of early warning signs. For example, miners used to have a canary with them. The canary would leave the mine when there was dangerous buildup of gases, and workers knew they had to leave as well. If the canary stayed in the mine, it was safe to work. That's what we want to have for the planetary boundary concept, to tell us whether we are venturing down a dangerous road. There's also work on defining a precise link between regional changes and global impacts. For example, if we focus on map C, we can see that the portion of the map is colored yellow in Northern Asia, Northern Europe, and Northern America. This yellow portion corresponds to land change in the boreal forest biome. It's a local change, but for sure it has a global impact because we're changing one of the most important biospheres, and we're also losing one of our most important carbon sinks. But a mathematical link between this change and the global impact it can have is difficult to make. We also want to redefine some key boundaries for the future. Climate change, for example, is measured by the control variable the CO2 in parts per million in the atmosphere. The threshold for the parts per million of CO2 in the atmosphere was set very high at the beginning of the planetary boundary concept. But we want to reduce it in the future because we know that the threshold for CO2 in the atmosphere is actually way lower than we first estimated. Biosphere integrity also must be changed. We used to measure it in part by the control variable species extinction rate. Scientists for the future want to use phylogenetic species variability, which is a measure of how many species are there nowadays that come from a same parent species in the evolution tree. Is that number of species from the same parent increasing or decreasing? If it's decreasing, we know for sure that the biosphere integrity is being compromised. Land systems change used to be measured with the amount of cropland on the planet. For the future, we want to measure it with the percentage of intact forest biomes for the three main forest biomes, which are the boreal forest I talked about earlier, the temperate forest, and the tropical forests. And lastly, scientists are working on redefining the boundary for atmospheric aerosol loading with a new control variable, which is the proxy I mentioned earlier, called atmospheric optical depth. For this proxy, we want to measure how much light are we getting today on the planet's surface, and compare this to how much light we should be getting with a clean atmosphere. The difference between those two measures is caused by the aerosol loading. So it will give us a general idea of whether we are above or below a threshold for atmospheric aerosol loading. And lastly, water's role. Water's role in the planetary boundary concept is bound to increase. It's already a key component in two boundaries: ocean acidification and freshwater consumption. But water plays a key role in climate change through its three states. Water as a solid, present as ice, is white, and therefore reflects light and water towards space, which cools down the planet. The oceans, on the other hand, water in the liquid state, can hold and capture water, heat for a very long time. Therefore, the more liquid water we have in the oceans, the higher the ocean levels, the more heat we're holding on Earth, and the planet heats up with that. The same goes for water vapor. Water vapor is a greenhouse gas. The hotter the planet gets, the more vapor there is, and we're entering a vicious cycle in which the water keeps heating up, and then which also causes the ice caps to melt, and therefore the heating, the rate of increase of the heat of warming in the planet increases. Water is also key in sustaining wild and human life. First and foremost, because we all need water to drink, but also because it is home to the biggest producers of oxygens in the world. Phytoplankton and cyanobacteria produce up to 60% of the planet's oxygen, and therefore their environment must be safeguarded to make sure that we have the oxygen we need to survive. Thank you very much for listening and listening to our presentation and watching our PowerPoint. We hope that you enjoyed it, and we invite you to like our video and subscribe to our channel if you want to receive more content on environmental and climate change concept.